Okay, so in this video I'm going to write a parser for mathematical expression based that are built from numbers, the four operations, maybe unary minus and variables and parentheses. So it will be a very simple parser, but it's just to show how simple it can be. I'm gonna write it directly using the C programming language without any external library. And also maybe I will also add how to do the number parsing. That is a little part that is less trivial to do, but is not really much code unless you are really in very edge cases. So let's start. Okay, so let me save this as a.c. Yes. std.h load mark.h. I think our strings maybe. Okay. Okay, this is let's see, compilation. Okay, so first of all, to do the parsing, I need a source of the characters. I'm now going to use a very naive approach that's just using a global instead of having an object to pass around. This may seem not general enough. I think that can scale to general enough, but let's don't go that route. I will just keep things simple. So I will need a pointer for the character. So I'm assuming that the whole expression is in memory. This is also used to be a big assumption in general for parsers. I think that for today, in today's computers, unless you are really parsing petabytes of data, assuming that everything is in memory is probably okay. Especially you can also just map a file in memory. So unless it's dynamically generated by something else, you are not going to need anything fancier. So I'm just using a char pointer. Okay, this will be our pointer, current pointer in the expression that we are parsing. Let me write a few utility functions. So int num, let's see, this returns if a character is a digit. So on c equals 0 and c less than or equal to 9. That's what is enough. Now for alpha, that is the same with the a and z, and also let's say uppercase 2. Oh, sorry. Or and let's see, let us include the underscore. Normally this is our identifier is defined in the C language, and then from of course it's just int C or C. Okay, compiles. So int and now, no, I think I need another function that may be useful. Is just to skip over white spaces. It's very normal in many grammars to allow for white spacing. So you can put space in many places, and those spaces are just for separation, so you just need to skip over them, how much spaces they are. So I will make skip spaces, and this is simply while source. So I'm checking a note at the end of the expression. I will use a null terminator. While we are still in the source and strchar, this is a function that checks if a character is inside a string. Just character return, tab, new line as spaces. C++. So this is our space skipping function. I think we have almost everything we need to start the parsing. And so parsing is inherently, as a problem, is inherently recursive. Because you have an expression, you can say have 1 plus 2 times open parenthesis. So this is another sub-expression. And so computing the expression is made up on, is built on computing sub-expression. In addition to this, there is also in what is normally used as arithmetic language for expressions, precedence and associativity rules. So if I say 1 plus 2 times 3, this part is as higher precedence, so it will be computed first. And this can also be seen as the sum of two expressions. So basically, expression will have a level, and this level will be level 0, numbers, variables, and say unary minus level 1 division, level 2 addition, subtraction. So I will have this kind of levels. So I need to, let's double is our eval, is the function we want to write. I need a level. And for simplicity, I say define max level 2. And our recursion, there will be multiple recursion, two levels of recursion. One is parentheses, the other is calling on level -1. So an addition is made up of adding and subtracting chains of multiplication and division. Each chain of multiplication and division is multiplication and division of numbers, variables, unary, minus, and some expression. So these are our, it's basically what the base case for recursion, what stops the recursion, even if include another recursive call. What is important to notice is that the recursion will not go forever, because we will be always either decreasing the level or consuming characters. So we are always going in one direction and always making a little step. So when we get to level 0, we only recurse after consuming characters, and above we will always at least decrement the level. So this is not going to go into infinite recursion. Okay, so level equals 0, else otherwise I will have the rest. So for level 0, we start by skipping spaces, and now we have a few cases. The first case to say is probably the simple one, is one simple logical one. It has some complexity, but I will get to this later. If it's a numeric character. So if the current character is numeric, then I know I've been I begin a number. Oh, I'm using double, so maybe equal to the decimal dot. I'm not considering -1 a single a number entity, and this is also how it's done in many programming languages. And the reason is that there is a sort of an ambiguity. Is this unary minus followed by a digit or just a number? So is, for example, this 2 minus 1 is just a sequence of two numbers? So to avoid this kind of problems, numbers do not have a unary minus in front of them. Unary minus is a mathematical operation, and if you're writing a compiler, you can then, when you have a unary minus right before a constant, you can just flip the sign of the constant, but that's an optimization. From the grammar point of view, when I'm approaching an expression, when I'm expecting an expression and I see a minus sign, that's a unary minus for simplicity. And so numbers won't be negative numbers. And so, okay, I got to the first character. What should I do? In this case, I'm using, for now, just the standard parser of the C library for the number. And I need a chart pointer to store where the parsing will end, because that's how it was the library function. And it's strange that it's not a constant pointer. I think this is a bug, but requires a chart pointer. The API has been written that way. It doesn't make much sense to me, but that's how the API is defined. So double E equal strtd of source ampersand end. In passing where to store the end, because strtd will automatically stop when the number is complete. And if key doesn't work, end won't be filled in, and strtd will return 0. I think also sets erno, but I'm not going to check erno. I hate erno, and you should too. And that was a very bad idea. So strtd, I basically do, so if not end, we got a problem. Invalid number. Okay, maybe I need also something to give an error. To simplify, I will just close the program on the spot. Error after point message. Yeah. Okay. This is just for simplicity. I'm not going to handle recovering from errors. So invalid number. Otherwise, it was a valid number. So I just need to do source equal to end and return v. Okay, telling me I got to the end of the function, but until everything is fine, everything is correct. Okay, so we got our number handle. Another case is if easy case source is the minus sign, like I said before. In this case, we could just skip over, and then we will call, we'll just return minus eval 0. Okay, this is important. I'm passing the level 0 because if I say minus 3 times minus 1 plus 5, when I'm here, I don't want to pass a full expression. I just want to pass the number 1. This is the terminal, the end, the lowest level. So minus is this is a term, and minus is followed by a term. So that's why I'm passing 0 and not max level. And that's it. So this takes care about the unary minus. Then I will have, for example, parenthesized expression. Source is equal to open parenthesis SLC++ will be equal eval max level. Here I'm using max level because I have an open parenthesis, so I'm expecting a full expression that can include addition, subtraction, variables, anything, and then a close parenthesis. So this recursion uses the max level. Then I skip over spaces, and if our source is not a close parenthesis, then we have a problem because we were expecting a close parenthesis. Otherwise, we increment, skip over the close parenthesis, and return the value that we compute. And this is just to repeat, this is important to note that here we are not calling recursively. There is no recursion here. Here there is a recursion call, but I have been advancing the source character pointer, so this is not going to go forever. And the same here, I advanced the character twice actually, so it's not possible that this call loops forever, because I advanced the character, then I compute recursively. So this is clear from a logical point of view, but even from a formal point of view, I'm sure that this code cannot run forever because of recursion. And there is another loop, so it's a formal definition would be, a formal proof would be, of course, much more difficult, but we know that this code is not going to loop. The algorithm is simple. And okay, I think I got numbers, unary minus variables. I think variables missing. So if alpha start C, and just I remember where the variable name starts. C, and then y alpha name starts C. C++. I'm just moving the pointer, advancing until the variable name ended. And here I can just assume that I'm going to write a lookup function, and we'll just return the others, the lookup. So let's say that I will do return start lookup of the variable starting at 0 and source minus 0. This is a function that, given a pointer to character and the number of characters, will return me the address of the variable, because I also wanted to be able to assign the variable. And I'm just writing it. Okay, I don't have this function, so let's write this function. Variable. I will have a stroke. For simplicity, I just use the linked list. Next, value, and let's say char name. I'm using here variable side structure, so in just the name will be at the end of the structure, so I will allocate the different sides depending on the name, and just using a C string with some data before in memory. And okay, so first variable. So this is or linked list. I'm not using an hash table. I could make actually an hash table without changing this definition, but for now we just use a simple linked list. And so I have a double pointer lookup function pointer name inside. I'm not accepting, like I shown before, just a C string, but I'm passing explicitly aside because I already know that I'm gonna need this call from the middle of an expression. I don't want to make a copy of the string just to be able to call lookup. So I'm making lookup to accept directly a portion of a string, let's say a string view or something like that. And what I need to do, I need to check my variable list. If it's there, I return. So for variable pointer e equal first variable e equal next. And for all variables, if strncmp, this is a comparison up to n characters of the name size. So if the name up to size matches and the variable name ends here, so this is the null terminator, we found our variable, so we just return ampersand the value. If we didn't find the variable in the list, I need to create a new variable, and that's very simple. I say variable equal malloc size of variable plus how many characters I need in the variable part in the end of the structure. I just size plus the null terminator. If there is no memory, okay, and otherwise I will just say next equal first variable equal v, the value equal to 0, and here I need to copy the name, so cpy name size and name size equal 0, and I return let's see if this compiles. Yes, so everything seems fine. So this is how we handle the variable lookup. Like I said, this is a linear list, but changing to an hash table, a closed hash table, for example, with just a few lines of code, just using the linked list for the collisions. And I think, I'm not sure if this is named open or closed or whatever, but it's so can be also extended to something that runs fast. Okay, I think that we completed all number variables, unary minus parenthesized at expression. So level 0 is complete. If we get here, we have a problem because I was expecting an expression and it's not one of those cases. So error expected. This should never happen. Okay, now the other case is when we have operation, and this is may seem strange, but it's actually simpler. And one simple way to do it is double x equal eval level -1. So if I'm computing an expression, a full expression is made of addition and subtraction in a chain. An addition and subtraction is made by multiplication and division in a chain. And multiplication and division in a chain is made up by numbers. So this is the first element of our chain. So level is not 0, so we are passing a chain of operators. But so here we are calling the previous level, and then I'm making an endless loop where I skip over spaces, and I'm just making a simple case. So if level is 1 and start 3. So if we are at level 1, sorry, and the character is a star, we have a multiplication. I can just make sus plus plus and x times equal without level minus 1. And the same for division, but of course we will have division. For level 2, I will have instead addition and subtraction. And of course those are all else. And otherwise, our chain terminated. Because the operator is not the correct one I'm expecting. Okay, this should complete the whole thing. And as you see, this is handling several operations in just a few lines of code. And exactly possible, not difficult, to put all of them in a table. So having a table of operators with precedence and even different associativity. I'm not going into there, but it just depends of your calling level or level -1. So this is for left. This is for left associativity. This is going to be a right associativity. But for now, let's just ignore. I'm just using left associativity. And just a little note I want to make. If you are creating your own grammars, keep the grammar simple. And this is for two reasons. One, because writing the parser is simpler, but this is not the important reason. The important reason is that grammars, most often, are used by humans. So you don't want your grammar to be complex. And it doesn't make sense. You want to be as simple as possible. So left associative, right associative, all this kind of stuff, to my eyes, my personal eyes, it's already too complex for no reason. So in recent years, I've been switching. When I experimented with languages, I'm working with something much simpler than this, where there is not even the operator idea is not present. So that I don't have precedence rules to care about, and the language can be very simple, very direct. But if you do still love this kind of complexity, please remember that it's a human that has to write the expression and also to read the expression and pass mentally the expression. So if your grammar is complex, you're not going to have happy customers for your grammar. And you can end up with monsters, with truly monster like C++ grammar that is just a pile of nonsense. Rules with everything is complex in C++ for no reason. So just be careful. It's not about writing simple code. That's a nice plus, but important is keep the grammar simple because it's for human. And in many cases, a human is going to need to write and read the code. Okay, this digression apart, I can now, let's write a little helper function. And that is, let's say, let's call this eval1. I think I need to put this. Okay, so I'm using eval1 and we keep eval for s. We make source equal to s. return equal 1. There is one little thing. Probably I need to do double. The correct thing to do is double equal eval max level and skip over spaces if start source error extra characters and expression. I'm assuming here I wanna the string I pass is the full thing that should be evaluated. Eval works this way, and so any extra is gonna be unexpected. Return B. For example, if I write 1a or 1x, this is gonna be a syntax error, because after 1 I was expecting the expression to terminate. If there is an x, probably missing an operator or something. So this is why I'm calling the parser. The parser wouldn't stop here. 1x wouldn't be a problem. We'll just return 1 and source pointing to the x. But I want this to be an error. So after evaluating my expression, I'm checking there is nothing else after. This is sometimes may happen as something that is forgotten and can lead to bugs. I'm talking from experience here, because we had for a long time a parser that was accepting actually trash after a valid expression because we forgot to check, and it's a mistake you don't want to do, because it just took us long to find the bug, because the configuration file was wrong, but there was nothing wrong in parsing it, so just getting the wrong numbers. Okay, so that's it. Okay, let's make some little test. I'm gonna make +1, 1 plus 1, 1 plus 2 times 3. Let's add some spacing. 3 plus 4. And x plus 1 times x minus 1 with some random spacing, and I say no. And okay, so 4 equals 0. Test E plus test E. No, let's see if this compiles. No, I got max level 2. Okay, what is the error message? Oh, it's not eval, it's eval 1. Okay, so everything seems compiled. Let's check. 3. Let's see. Oh, let's see it worked. Allora, so 1, 1 plus 1 is 2. This is 7, correct? 7 spaces. This is 2 times 7, 15, correct? X is a variable, the value is 0, and exponent 1. So everything seemed to work. And okay, there is one problem. We don't have a way to do the assignment. So here I'm gonna play a little trick. And this trick is for variables, this kind of structure, just returning a double from evaluation, doesn't scale well for assignment. And the reason is when I have an expression x, if I return the value, I have no way to assign the variable. And using tricks like I will assign the last variable that was assessed does make sense. You have to use more sophisticated techniques like building an AST, or introducing the idea of L values, and those are complexities. For now, I will just allow an assignment to be on the top, the beginning of the expression. I won't allow an equal sign anywhere else. And to do this, I will still play a little trick. That is, a skip over spaces here, and if alpha is star source, so if this is begins with a variable, I'm gonna check if there is an equal sign after. So to do this, I need to do this kind of trick. Once char 1.0 equals source, num star source plus in size equal source minus 0. And now I skip over spacing again, and if star source is equal to the equal sign, let I know this is an assignment. And being an assignment, I will set normal pointer var null. If this is okay, I say var equal lookup without the star and just reading the address, lookup of F0 size. Okay. Otherwise, I am going back. Source equal to F0. Okay. I pretend I didn't read. I didn't skip it over those characters. This is kind of a trick, and I think was fine for. Would be a perfectly valid solution for this case, just for allowing variable assignment only as the first at the beginning of the expression and without parentheses. So it's not a normal operator, it's part of the syntax. And like I said, this is what is called that you need to look ahead to decide what to do. So I'm basically saying that my grammar is ambiguous, and you should try to keep this at a minimum, because it's annoying, even for a human. For a human, if you just write simple stuff, x equal, that's not going to be difficult to understand. It's just a name. But every time you have this kind of stuff, an ambiguity that can be solved this way or other ways, you are making the grammar harder to understand for both the parser and the human, and you don't want to end up with the most vexing parse of C++, where an arbitrary number of tokens must be parsed before deciding what is the semantic meaning of the first one of them. And this is just distilled nonsense, but this is what C++ is, unfortunately. And that's it. I think we have all of it. So now if I say, let's see this, I don't know what is this. This should be uh, 54. I can do +1, and then I want to print again x times x. So let's see if this works. Okay, set was not used. Oh yes, I forgot the most important part. After evaluating, if there was no error, I can say if var star var equal star var for b. Okay, let's see. Okay, this didn't work. Why? Oh, I know why. Because I forgot to skip over the equal sign. So after reading the name, the equal sign, I need to take it from the expression. Okay. And now since working, because this is 12, the value of the expression is the sign. So this is now 144 because the lookup returns the 12. Now I'm incrementing the value, and this is 169. And this is x squared minus 1 squared. So that's okay. Okay, I said there was just one little thing I could add. I may want to add, and this is the fact that I could implement the parsing of the number here. This is not going to be very difficult, but just to show how to do it. I'm not saying you should do it, because doing perfectly is very, very difficult. And this is because numbers are represented in binary form, and in expression you're writing in decimal. So the computation, if you want to get the number correct up to the last bit of accuracy of a double precision number, that's very difficult to do. And doing fast is also extremely difficult to do. Not kidding, I don't know how long we started, since when we started using floating point numbers, but that was many years ago. Every new algorithms are coming up every few years about parsing them faster. So this gives you an idea how complex can be. We have been working on this from 50 years and still working on it. Of course, just writing the parsing on a write is not going to be super accurate, but will be for most cases will be more than okay, and will be still faster than str2d. I had to write this kind of stuff for speed reasons, because str2d was too slow for my uses. And so how it works. One simple solution is having double accumulator. I start with an accumulator. I don't have to care about negative sign, because I know there is no negative sign. And I say double accumulator, let's say numerator, and then equal 0, or I say numerator, okay, and equal 1. I will think about this later, let's say. So first of all, I want to get all the integer part, where it is. So I will just do while start source. I will just do numerator equal numerator times 10 plus start source minus 0. So I'm accumulating as an integer number all the digits I find, and of course I need to increment. I normally write this kind of stuff, and I actually try to keep vertical space if there is no real need for structure. So this is for me easier to read. Of course, what is readable depends on the eye of the reader. For me, I prefer this for this kind of compact form, to have more code on the screen. And so this is a loop for the numerator part. Then I got if start source is equal to a decimal point. I'm gonna skip over, and let's say this is the denominator 1. parenthesized plus plus. So I'm skipping over the decimal point, and now I'm keeping adding to the numerator as before, and now I'm doing this, but I also do denominator times equal, because every digit I read, that means that I will have to make a division for this number. And after I got this, also I needed to add a little variable int OK equal false. So if there is a digit before or there is a digit after, I don't want just a single dot. Single dot is not a good number. So if not OK, error invalid number. Say OK. I don't need the end pointer because I'm just advancing. If OK, not OK, invalid number. Otherwise, I may have an exponent sign. It's not an exponent, the power of 10 for scientific notation. So it start source is equal to E, or start source is equal to uppercase E. I'm going to skip over. If start source, I need to parse an integer, but this may be negative. So int neg equals 0. If start source equal to minus sign, so plus plus equal 1, and let's say let's equal 0. I'm gonna take this loop. Okay, if not none, start source error. It's expected exponent part. One nice thing about writing the parser by hand is that you can give accurate errors, because the code will reflect the parsing of the structure, so you can point exactly to where the problem is and giving a meaningful error message. If instead you are using some more sophisticated techniques that just breaks down and builds up, getting the error messages may be difficult. And here I'm going just exp times 10 plus and that's it. Okay. Okay, I think I can keep the flag and I think I can keep the exponent outside. I'm not choosing to use bool. See, it's okay. Normally just use integers, but let's try to keep these things a little better. So invalid number. So I got okay. I think this is our parser. As I said, it's not very trivial, but it's not terribly difficult. It's just a few lines of code. And what I told here is just numerator, denominator. This is not the best way to do, power 0. I don't know if this is gonna work. First, let's see if it compiles. Okay, I want int, so let's pulse 0. I don't remember see this thing about most of them work in C++ today, so I'm not sure. Probably is uppercase pool, something like that. And I never use pools in C, and I think it is was not a worthy addition for historical context. I mean, of course, it's a little better, but it doesn't gain much and just adds some confusion. So let's see if this compiles. Let's see if it works. Yeah, no, we passed the same as before. Of course, this is not a very good test, but let's try to do square, and now let's check it. 9 to 6. Okay. Times 2. Just out of curiosity, if our parser works. Okay, I got this. Let me check if this is correct. If I do a Python, things times 2. Okay, now seems that this is not the same, but maybe is another problem that is tied to how Python prints the floating point number, because the users simplify the form. So maybe those two numbers are the same. Let me check if this is the case. Maybe it's not, because that's not a perfectly accurate parser, as I said. But in this case, was parsed correctly. And what we are seeing here is that this number cannot be represented correctly in a floating point number. And so after parsing, if I ask for the decimal are different, because this is a different presentation. The floating point numbers inside is probably even different from this, and actually is probably something like so. This is let's say, okay, this is actually the number, the floating point number associated, the binary floating point number associated to this. Those are the real digits. And but this is because of accuracy of floating point numbers. It's not a problem in the parser. The parser is doing the correct thing. And but there is another trick that is often used by software that is not often, sometimes used. I think is a good idea. It chooses the shortest representation that what parsed back will give me the same floating point number. So parsing this number or parsing this number is exactly half this number is exactly the same. And so using the shorter representation is a better idea. That is what Python does. But inside it will be a different thing. Okay, this is probably, I just started the confusion. I should probably cut this part from the video. Not sure if I'm gonna leave the part in. I don't know, maybe I will just leave it. I'm too lazy to do the edit right now. Okay, thank you for watching. If you are what I think is that for some reason parsing is considered to be sort of black magic, something difficult, and there are some nasty areas, but it's actually not very difficult. This is, for example, about 50 lines, okay, from 47 to 1769, and I'm not even using a standard library for parsing the floating point number, so I'm parsing the floating point number myself. And so this is basically, this could be translated into assembly with not many changes. So it's not something that you need high-level libraries for. Of course, there is a level, something like that, but the core is just this. Okay, like I said, thank you for watching, and see you next time.